Hello, good morning, and very welcome back. Today we are going to deal with a new topic that is electric dipole. Okay, first we shall understand what electric dipole is, and then we shall talk about why do we study about this electric dipole. Okay, so let's start with the idea. Electric dipole is mainly consisting of two equal and opposite charges placed at a certain or a small distance. That's simply the electric dipole. There is one small charge placed, and that is another small charge, that is plus q, and that is minus q, right? And they are separated by a small distance, and that is twice of a. This is electric dipole. Remember, both the charges are equal in magnitude, but the signs are just opposite, right? This physical system consisting of two equal and opposite charges are simply forming what? Electric dipole, right? Now, what is the strength of that system and how do we recognize that system? That term is used, that is called electric dipole moment, right? That is dipole moment or electric dipole moment. Dipole moment is given by P is equal to either of the charge multiplied by the distance, that is Q into 2A, or P is equal to twice A and Q. This is the magnitude of something that is being formed by this pair of charges, and that something is to be utilized in different conditions, in the presence of different sort of fields and behavior of material or different sort of matters, right? And that particular name or property of that system is called electric dipole moment. P is equals to twice a q, right? Now, when this system is placed in, let's say, some electric or external electric field, its behavior changes a little bit, and on what factors its behaviors depend, or in other words we can say what is the strength of this dipole, that is given by this, and this strength is simply the magnitude of something that's been formed by this electric dipole. Agree? Now, this will be a vector quantity. So more specifically, we denote the dipole moment vector. P vector is equals to twice a q, and we place vector over here. So this is the general notation of electric dipole moment in vector form. Remember, this quantity specifying or characterizing this physical system is called its electric dipole moment. If it is a vector quantity, then it must have a direction, and conventionally the direction of the dipole moment is always from negative to positive. That is, this is the dipole moment of this electric dipole. Remember, the sentence is to be like this: the dipole moment of this electric dipole P will always be from negative to positive charge. That's it. This is simple mathematics regarding the electric dipole moment, and this is its strength, and it is the vector form. Third special thing is that it's always points towards the positive charge from the negative charge. Okay. Now, in case of ideal dipole, if we have an ideal dipole, then an ideal dipole consists of a charge which is very large. Charge will be very large, but the separation will be very small. these are not equal to 0 and this is not equal to infinity, but these values are approaching to these corresponding values. Got it? So charge has to be very, very large in microscopic level, not in macroscopic level, and this distance has to be very, very small. Then, so that the product, that is dipole moment, is equal to twice a q, is having a finite quantity. It has to be a finite value. That's it. Simply. Please don't get confused regarding P and vector P. This is the magnitude of the strength formed by this system, and that is the vector form of that magnitude or that characteristic property of the physical system. Remember, in the universe, every system has its own characteristic properties. Okay. Now, for examples, the examples of dipoles are very commonly HCl molecule, because H has a positive charge. They are formed by ionic bonds, transformation of electrons from one to other charge of atom, and this is negative. Another is sodium chloride. This has negative charge, it has positive charge. These molecules are formed by ionic bonds, but we have some molecules as well which are not forming of ionic bond, rather they are formed by covalent bonds. For example, H2O molecule, how they are behaving like dipole we shall study in later cases, and C2H5OH, these all are they all form electric dipole, or they have their own dipole moment, or rather they have a dipole moment vector. Okay, this is simply the introduction part of the electric dipole moment. We have two more derivations of dipole moment, that is, what will be the electric field produced by this electric dipole at different position. Okay, we shall see in the next section. Till then, please note down.